Yeah, good afternoon, everybody, and thank you for joining me for this webinar today. This is a little bit different, just to explain. So there's going to be a live introduction with me, then I'll go through a few slides just about what we're going to be doing. Then there'll be a video in the middle. So the video will take you through exactly what we did, but I'll explain that as we go, and then it will come back to me at the end where I can run through just some final thoughts and then go for some questions and answers if we have a chance. So as you can see, the title that I've put here is All That Glitters Isn't Gold, and if it looks too good to be true, then it probably is. And this is really about consumer product safety. And as an organization, we're often on the receiving end of poor quality, let's say that, poor quality consumer products. And what we did for this purpose of this was to go through and pick a selection of products that were widely available and put them through their paces and test them and evaluate them. But just before we do that, just a little bit about me. So I've been doing this, I've been working for TÜV SÜD for 25 years doing this. I'm basically, people come to us and, you know, they basically tell me where they want to sell their products, and then we advise them and do that. But certainly Europe, North America, everywhere else and beyond is not a problem. So, and before I joined TÜV SÜD 25 years ago, I studied as an electronics engineer, and I previously spent a little bit of time working for the UK Ministry of Defence, a bit of time in the health service and in industry. So what did we do? Well, we went out and purchased a selection of everyday consumer electronics, specifically 4 USB chargers and a hair straightener. Might sound an odd combination of products, but the reason we picked those products was because actually past experience tells us that they're problematic. Hair care appliances are generally problematic, and certainly USB chargers have their problems. So we kind of did this with a bit of intelligence in mind. The cheapest item we purchased was £1 in total, but it's important to understand that the purchase price was a penny and the P&P was 99p. So expectations from the outset weren't particularly high for us here. The most expensive item we purchased was £7. But again, that was 1p for the item and 6.99 P&P. All were readily available for sale in the UK, online to UK consumers, and were delivered to a UK address. And all items arrived from China. And I certainly don't suggest that's a problem. This is just stating the facts of what we did. Moving on to why we did it. You know, in our experience, we've done a lot of work. We've collaborated a lot with the market surveillance authorities and so on. And because the sheer quantity of low-cost electrical products available to UK consumers, our previous experience of working with organisations like the market surveillance authorities, experience of the safety gate. I hope most of you have heard of the safety gate, but it was previously known as RAPEX. This is the Rapid Alert System for non-food products around the European community. And if you'll get a copy of the presentation. If you click on that link, it will show you all of the evidence of what's been found on the market week by week. I also wanted to give you a bit of an insight to show what we really do when we test and inspect products. Also to spot check what was available on the market currently. So these were purchased at the end of last year, and to raise awareness of the issues and dangers. So that's why. And now I'd like to introduce the video. It's about 30 minutes, so I'll join you again after the video, but it takes you through and shows you exactly step by step what we did. So I hope you enjoy it.
So here are the products that we purchased online from the retailer, and these are the ones that we've selected for our testing and inspection. We've limited it to a range of USB chargers and some hair straighteners. So what we'll do over the next few tests is to have a look and just see how well these things are constructed, how well they perform, and what the overall electrical safety and EMC performance is like. So let's take a look and see how they do. Okay, let's take a closer look at these USB power adapters that we purchased from our online retailer. So we've got 4 power adapters here. Interestingly, only one was supplied with a box. The box actually is very beaten up. That may have happened in transit, so we'll give that the benefit of the doubt. But interestingly, what you can see is these are standard Apple design, both this one and this one, And if we even see on the box, it actually says Apple. So these two at the back are clearly counterfeit design. So not a good start on that front. The other two different shapes, so this one is circular in design, dual USB output this time, and this one same kind of shape, but again dual USB output. So let's take a closer look at each. Well, first thing we can see on this one is that actually the writing is incredibly small, quite difficult to read. I can only just read that, but what I can make out is it has CE marking, safety certification mark, cross wheelie bin, but incredibly light. It doesn't give me a good feel in terms of quality and safety. And the plastics also feel quite cheap, quite low quality. But let's come back to that one in a second. If we look at our second one here, well, this is very interesting because it's almost identical to the first one. So again, counterfeit design. Markings, incredibly small again, very difficult to read, not what you want in terms of safety information and safety markings for the consumer. Incredibly light again, very worrying for me. Really makes you wonder what's inside this thing. And yeah, plastics again feel quite cheap. Plug pin design doesn't look too good. Moving on, let's have a look at this one. Actually feels a little bit more weight to it. Markings, much better on this. I can actually very easily read that, easily read the information. It has CE marking, it has the double insulated symbol. A little bit more confident about that one. Still feels a little bit cheap in terms of the plastics that are used, but we'll take a look in a bit more detail later. Finally, last design that we have, different design, circular design. Plastics again feel very cheap, and the weight, there's hardly any weight to that at all. But again, on the plus side, we can easily read the safety information. It has CE marking, it has the cross wheelie bin sign. So the very first test that we'll apply is we'll take our standard plug gauge. This is a gauge that allows us to check whether we can actually safely insert these into the standard main socket outlet at home and remove them without causing damage. The last thing we want to happen is for these to break, leave parts exposed in the socket, you know, and just cause people a problem when they go to insert and remove them. So let's look at this one first. Well, it started off very well, but actually I can't engage it. I can't engage it because it's too big. The diameter is too big here. It overlaps the plug gauge. I can't fully insert it. So that's a fail on the first one. Let's look at the second one. Actually, that doesn't feel too bad. And plug pins don't protrude too much. Nice and easy to insert and remove. I would say that's probably okay. Let's have a look at this one. Oh, this is interesting. So straight away there's a problem. That's about as much effort as I can apply to insert that, and I can't get it to fully engage. So the pins are the wrong dimensions, the wrong size, the wrong fit, and actually it takes quite a lot of effort to remove it. So again, that's a clear fail. I would imagine this one will be similar. Let's take a look. Well, actually, it takes a little bit of encouragement to push it home. You can just about, I think you can hear that. It takes a little bit of encouragement, but it's okay. So, initial conclusions with the plug gauge. Well, 2 out of our 4 have failed that test. Not a very good start. Let's take a closer look. So here's the first of our USB chargers. I've actually taken a picture and enlarged it to make it a little bit easier to see. So certainly it does have 100 to 240 volts, which is good, 50-60 hertz, 0.15 amps. It's got an output rating. It's got the double insulated symbol, the cross wheelie bin symbol. These are all good things. What it doesn't have though is manufacturer's name, identification, trademark and so on, and a model number, which is required by the standard. So not bad, but still a fail. Okay, if we take a look at our second adapter, so this time, interestingly, we do have the CE marking, as you can see. We've got a safety certification mark, cross wheelie bin. This time there is a manufacturer's identification and a model number. I'm not too sure that those are correct, but nonetheless. And there is a rated voltage, 100 to 240 volts, 50, 60 hertz, 0.15 amps. There's an output rating, but critically, there's no double insulated symbol. So again, it's okay in terms of markings, but it's still not right for the standard. That's another fail. Okay, let's see if we can get third time lucky. So this time there is a model number, no sign of a manufacturer though, does have the electrical ratings, input and output, does have CE marking, does have the cross wheelie bin, but once again, no double insulated symbol. So 3 out of 3, it's not right for the standard and it's another fail. And moving on to the last USB adapter. So again, CE marking, safety certification mark, crossed wheelie bin, electrical ratings. There is a model number. I don't think there's any sign of a manufacturer's rating. Maybe this is a reference here, but I'm not convinced. And there's no double insulated symbol. So that's a clear 4 out of 4, non-compliant and failed with the standards. Okay, so I just wanted to take a bit of a closer look at this adapter here. First thing, it doesn't feel very sturdily put together if we have a look at this, and actually I'm just a little bit skeptical. Yeah, this is what I feared would happen. I can actually pull this apart by hand, which, okay, I needed to apply a reasonable amount of force to do that, but you should never ever have some plug-in electronics like this that you can actually separate the case by hand. That's really, really bad. I've also noticed this wire's detached. I think that probably detached when the case opened, but, well, this is very interesting because if you have a look now, although there is some solder on the end of this wire, there's no evidence that that was ever really securely attached to that pin. And this is carrying mains voltage. This is where it plugs into the supply. So 2 problems. We can open this up by hand. That's really, really terrible and clearly would allow somebody to be easily electrocuted. And this mains wiring really, really substandard. So we already know that with this adapter it can be pulled apart by hand, which is clearly not right and not with the standard and very unsafe. But let's have a quick look what else we have. So, you know, the soldering is really quite poor. I'm quite shocked actually, because if you take a look, wow, even without taking this apart, look how close the shield, the accessible shield of this USB connector is to the mains transformer. But let's give it the benefit of the doubt and take a look. And okay, this is interesting. The isolation barrier, you can see an isolation barrier on here because it runs through this if I turn that round, runs through this opto-isolator here in this transformer. But actually we're looking for at least 5 millimeters around there, and if I take a measurement at the smallest point, well, it's around 1 millimeter, just over if I give it the benefit of the doubt. So really not very good. Implications of this is, you know, this safety critical isolation is the only thing that separates you from the bits you can touch, this USB port here, from the mains voltage. So significant risk of electric shock and electrocution. Really not very good. Okay, so let's have a look at our next USB adapter. And if we take this out of the enclosure and have a look, well, we can see an interesting arrangement here because there's a clip and pin style arrangement on here to attach this base plate with the mains pins. And if I have a look, yeah, it's fairly well connected on this side. On this side though, very, very loose. And this is a mains connection after all. Never a good idea to have a connection that may not be 100% reliable, because you could get localized heating if you get a bad connection. If you get localized heating, you could end up with an electrical fire. So not a great start, but let's carry on and see what we find. So again, if we have a look on this side of the board, well, again, a little bit surprising for me is we've got, you know, very, very close proximity from some mains parts here and here. These are the main supply connection terminals, mains transformers here. You know, our accessible USB port is only here. So top side of the board, not looking too good at all. Let's flip it over and have a look. Well, we've actually got a fairly well-defined isolation barrier that runs down through here. So it runs through the opto-isolator, through the transformer, comes on down, but goes horribly wrong around these areas here, because if we have a quick look, this is our incoming mains terminal. The adjacent pad is to connect the shield of the USB connector. So this is all that separates your accessible USB port from the mains, this small gap here. And that maybe is around 1mm, but I'm not even going to measure it because it's far less than the 5mm that we're looking for that's required by the standard. So overall, not a very good design. Definitely a risk of electric shock and electrocution. Pretty bad. So now if we have a look at our third USB adapter. So let's remove the enclosure. Well, if we start off looking at the circuit board, do you know, the first thing actually is it's actually very difficult to make out any kind of isolation barrier on here at all. So what we can see is that the mains terminals, mains wiring comes in here and terminates here. This is, I think, is a bridge rectifier here. So we've got primary circuitry everywhere. This is definitely our low voltage USB port where that connects. So I get a very bad feeling about this one just from looking at the circuit board. Let's have a quick look. Wow. Actually, this is really terrible, because there is pads here where the mains pins connect and the wiring terminates the mains wiring. And then you have the metal shield here, and this USB connector is on a compressible sticky pad. When this is reassembled, that's going to compress. And this gap down here, I can barely get my pencil in here. It's absolutely tiny. So without a doubt, this does not meet the creepage and clearance requirements. It's probably about the worst one that we've looked at out of the three so far. What can I say apart from really terrible, significant risk of electric shock and electrocution? This is just absolutely terrible. And now let's take a look at our fourth USB charger. So let's take this one out of the can to start with. Okay, there we go. Well, actually, there's some fairly encouraging signs here, because these slots are actually normally put in to maintain creepage and clearance distances on circuit boards, which actually makes me think that somebody's thought a little bit about this one. So if we just follow this through, we can see our mains connection comes in here, connects through this resistor. So what we can tell is that all of this stuff up here is primary side. This stuff down here is accessible secondary circuitry connected to the USB connector. And if we have a look at this, we can actually see a fairly well-defined isolation barrier, but I still don't think it's going to be acceptable, because we're looking for around about, or at least 5mm. And if we have a look here at the smallest point, we're around 2mm, something like that. So it's not going to be okay. It's not enough. But certainly it's better than the other USB designs that we've had a look at up to now. And if we turn it over, well, there's a few other problems that we can actually start to identify, because this is a safety capacitor here, I'm pretty certain, so we can assume that this insulation has some degree of safety isolation. But these are standard capacitors, and well, there's nothing to stop me actually bending this one over and touching this capacitor here, and what that does effectively is bypass the isolation barrier, short circuits it completely. And of course you can't control this in production. The only way you could really do that is to secure that with some silicon sealant or something similar, but at the moment it's just flapping around in here. There's a few other issues as well. There's very, very long lead outs that have been left untrimmed. These could potentially move across and compromise that barrier as well. So, you know, it's the best one that we've looked at out of the 4, but unfortunately still doesn't meet the requirements of the standard. We've now concluded our internal inspection of these USB chargers, and we have some pretty serious concerns about the construction and the ability of these things to protect people from the risk of electric shock. But just as a final verification step, we need to apply some additional tests, and we'll do some electric strength testing. That basically involves applying a high voltage, typically 3000 volts, between the live and neutral pins connected together and any accessible part or any part you can touch, the enclosure for example. I don't have high hopes for this because of what we found previously. I think we're going to end up with a whole load of failed tests, but let's do the testing and see what we end up with.
You want my summaries?
So let's take a look at the hair straighteners that we also purchased from the online retailer. Again, arrived from China, not necessarily a bad thing, but on first impressions, box is looking pretty battered, pretty tatty, and you know, there's some clear signs of that something isn't right. Mini straight A-dual model, for example. However, It does say that there was a model number. It says it's rated 220 volts, 50 hertz. So, well, let's open it up and take a look and see what we find. Okay, so there is a little bit of a surprise in that, well, take a look at the plug. We haven't actually got any means to be able to plug it in, because that is certainly not a plug that's suitable for Europe or the UK. More worryingly is there's absolutely no sign of any CE marking, any electrical ratings, and it feels pretty poor quality. So we can't even do the plug gauge test on this one. So initial findings not looking great on this, but nonetheless, let's open it up and take a closer look. And just when I thought things really couldn't get any worse, if we take a look at our hair straighteners, there's absolutely no warnings or markings on them at all. It's clearly not right in accordance with the standard. So that's an out-and-out fail. Okay, so let's take a closer look at the hair straighteners. So we already know that there are some problems with these, but let's take a look inside and find out if we can spot anything else. So that comes apart relatively easily. Let's take a look at the bits with the electronic control first. Okay, so that comes apart relatively okay. If we have a look at the heating element, well, first impressions on the heating element actually pretty good. We can see some nicely insulated wire. If we slide this out of here, yeah, actually fairly impressed with that. It's got some good insulation on there. You know, I'm not going to take this off and count the individual wrappings, but it actually looks pretty good. So I'm quite encouraged by the heating element that we've got in here. Now let's have a look at the circuit board. Okay, it starts to go a little bit downhill here because we've got what looks like flux residue left on the board. The wires have just been tacked on. You know, you can see they're not hooked in, they're not additionally secured. Good safety practice is to hook through or have some additional mechanical fixings. There's some, I don't know what this is, there's some residue left on the board down here from something. So that's not so good. I did also spot something else that was a little bit concerning when I had a look here, and that's all to do with these mounting pillars here for the screws. And there's a couple of things here. You can see that actually the plastic's split. I think this is just you know, a victim of a low quality plastic, a low quality mold, and I think when the screw's been inserted, it's split the plastic, which is not great, but you know, we can live with that. The bigger issue for me though is that we've got wires, you know, mains voltage wires that run either side of these pillars, and not so bad here because we can actually locate them fairly well, but down here very difficult to locate them. And if this gets pinched or severed by the screw when it's assembled, then straight away you've got a pretty significant electric shock risk. So not very good. That's pretty poor. And the low voltage, European low voltage directive that we work to also says that we have to consider you know, consistency in production. So how you can expect to control this, I really don't know. So not so good on that front. Let's take a look on the other side. Just while I'm doing that, it's also interesting to note that there's very little in the way of components on that circuit board. So it's clearly a very low cost design that we have here. So let's get that out of the way. Yeah, I think we're going to find the same. Yeah, again, heating elements I'm quite encouraged with because there's a reasonable amount of insulation on here. It's the routing of these wiring. I think that's going to be very, very difficult to assemble consistently in the factory without trapping those wires. And if you trap the wires and damage those, as I said earlier, high risk of electric shock and electrocution. So in summary, not so good. You know, we originally found that it didn't have a UK mains plug. Quality wasn't very good. There's no markings or warnings. You know, I think there is a small marking warning around the switch just to indicate the on-off position, but that's it. So yeah, pretty low quality, pretty poor product, and it definitely has some safety concern.
Okay, so we've come to our EMC laboratory just outside Stratford-on-Avon today. We're going to be doing some radiated emissions testing on the USB chargers. We're not very hopeful about the outcome. We don't think they're going to be compliant, but let's give them the benefit of the doubt. Let's do the test and see what the results say. Okay, so we've now set up our first charger to test. So we have it plugged into our standard main supply here, and we've got the output connected to a resistor load bank that you can see here. So now what we'll do is we'll run our radiated emissions test and see what result we get. So now our testing is completed for the day, and here are the results for all 4 of the chargers that we tested. I'll explain why there's only 3 plots in a moment, but on the left hand side, the worst failures by a country mile were clearly the 2 double output USB chargers, and they're both shown on the left hand screen, and you can see that we've got multiple failures shown on both of those. On the right hand screen, actually that's the single output charger, but when we tested the second single output charger, the plot was pretty much identical. So again, failed. So the message from today, actually all of the chargers that we tested all failed the requirements of the standard. The double output USB chargers failed pretty spectacularly. Okay, so finally we also tested our hair straighteners that you can see here. Actually, these were pretty good as far as EMC is concerned. These passed the test with no problem at all, so well done for the hair straighteners.
So we've now finished our evaluation of the USB chargers and the hair straighteners, and I hope you'll agree with me that it's been quite an enlightening journey that we've been on together. It's been great for me to be able to show what we do as a test lab when it comes to these kind of products. But critically, I guess the message is that these things are not safe. They do have some pretty serious safety concerns. Everything we tested, actually, all 4 USB chargers had problems, the hair straighteners had problems. Okay, some were a bit better than others, but we found some pretty fundamental safety flaws in everything that we looked at. The 4 USB chargers also failed the EMC test that we applied. The hair straighteners did pass the EMC testing, but hey, I wouldn't really want to use them myself, not that I have a need to. But my message here really is a simple one, and it echoes the title of this presentation. You know, perhaps all that glitters is not gold, and actually, if it looks too good to be true, then it probably is. All of these things we bought and purchased from our online retailer actually cost just £1 or £2. You know, they were all very, very low cost products. So, you know, what appears to be a good bargain at the end of the day isn't always what it's cracked up to be. But my real parting message for everybody is, I guess if you're a consumer, you know, just go into it with your eyes open. My recommendation to you is please pay a little bit more, buy the brands, at least you know that these things have been properly tested, they're properly compliant, and they're not going to give you any problems down the line. And even if the safety and EMC stuff doesn't interest you, you know, if you've just spent £700, £800, £900, £1,000 maybe on a phone, then do you really want to plug it into something like this? Because I'm not sure that I do, to be honest. And then my message to the manufacturers and the retailers and the distributors, anybody that's involved in the distribution channel for these things is, you know, these things are available. We've demonstrated it. We went out and purchased them, we've evaluated it, and we found there's some serious deficiencies with them. So, you know, don't let that be you. Engage the services of a test lab, check your suppliers, check the documentation, do some product checks. If you don't want to go through a test lab, do it yourselves, but please do something, because we need to do something about this kind of stuff on the market and get it off the market. Finally, my message to the regulators, to the Commission, to the market surveillance authorities and so on is we have some good regulation in place, we have some good laws and everything else, but something isn't working, something needs to change, and we need to make sure that these things are not available for sale to consumers in the UK, in Europe and beyond. So, to all stakeholders, let's really embrace this, let's do something about it, and let's make sure that we all have safe consumer products to work with. Thank you very much for listening, and I hope you've enjoyed the video as much as I've enjoyed making it. Now I'll be happy to answer any questions. Thanks very much. Bye-bye.
Just to conclude, what was in the video was the tip of the iceberg a little bit, really. So, there were some additional areas that we didn't investigate, such as the quality. What I mean by the quality is the flammability of the plastic materials used. Some of that felt pretty poor. And we also had some concerns about the fusing. And if you just have a look at the pictures at the bottom of the screen, I'm pretty sure that these traces that you can see, I don't know for definite, but I'm pretty sure they're an attempt at fusing. Well, to have a fuse as a bit of circuit board track is not okay. Fundamentally, you look at the right hand adapter. So these are 3 of the ones that we tested. On this one, there was no evidence of any fusing at all. And as a next step, then we'd start to have a look at the transformer, which is what I've circled there on the third photograph, and we'd have a look at those. But I also get a pretty bad feeling about those because of the general size of them. But if we just move forward onto the next slide, I just wanted to leave you with 2 here. The one on the right will take a bit of explaining it. I had a bit of difficulty getting a good photograph of that, but I'll explain what you're seeing in a minute. But first off, I looked at another one of these adapters, and the first thing that happened was it came off in my hand. And this is what you would traditionally call the earth pin, but is the shutter opening device. And okay, it means that you can't, you then can't operate the isolated shutter part of the plug to plug it in the first place. And if you're a consumer and you want to charge your phone, perhaps you're going to try and force it and do something else. It's just really poor quality. On the right hand side, this is quite scary, and I've actually broken away and cut part of the case away here so you can see it. Look in the red circle. At the bottom of the red circle, you can see the top of the mains pin that comes through. That is actually touching that component above it, that round component you can see the end of, which is a capacitor. And that capacitor, in turn, is touching the metal can, the USB connector. So all this talk about having a millimeter or so separation, well, in this one, when you've actually assembled it, you've got absolutely no separation at all. And that really brings me to the end of my presentation, and I hope you've enjoyed it. I enjoyed doing this and making the video. It was a bit of a trial for us, so I do apologise once again for the technical issues. But thank you very much for listening, and yeah, I'll hand back to Anna.